Hello everyone. So today let us look at the problem called number of enclaves. So we have been given an m into n binary matrix grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent 4 directionally land cell or walking off the boundary of the grid. Return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of moves. Okay. So in this example we have this matrix. Okay. What is the number of land cells from which we can walk out of the grid in any number of moves? That is this one, this particular grid. If we take one move to the left, we can walk out of the grid, isn't it? But if we look at these three land cells, in any number of moves, we can't walk out of the grid, isn't it? If we go up, it's water. If we go left, it's water. If we go right, it's water. We come down, it's a land cell. But if we go down again, it's water, right? We can go in only 4 directions: top, bottom, left, and right, isn't it? This is diagonally connected. We can't move diagonally. So these are the 3 land cells from which we can't walk out of the grid in any number of moves. So 3 is our answer. If we look at this example, we have 4 land cells connected to the boundary. Okay, so if we go up and up and up, we can easily walk out of the grid, isn't it? So there is no such land cell. If we stand on that land cell, we can't move out of the grid. There is no such land cell. So the answer is 0. Okay, now let's see this example. Okay, what is the number of land cells if we stand on that land cell? We can't walk out of the grid. It would be this one, this one, this one, this and this. Why? Because if you see, if we move in any direction, there is no way we can walk out of the cell. Okay, I mean the grid. Okay, but if we look at these blue land cells, okay, we take a step to the left, then again left, then again left, we can easily walk out, isn't it? Similarly for these ones, we can go to the left, go up, go up, go right, go up, go up. We can walk out easily, isn't it? So these land cells are not going to count. Similarly these ones also. Okay, so 1 2 3 4 5 6 7 8 9. 9 is going to be our answer. 9 is the number of land cells in our given grid from where there is no way we can walk out of the grid. Okay, so how are we going to solve this problem? We need to count the number of cells from where we can't walk out of the grid, right? So if we count the number of land cells, okay, that is the cells which has a value 1, right? So this cell has a value 1, this cell has a value 1, all these yellow cells are 1, right? But similarly these blue cells are also 1 valued, isn't it? So we need to make sure that we don't count them. Okay, so how do we make sure that we don't count them? What we are going to do, we are going to sync all those land cells, okay, which are connected to the boundary. Okay, if they are connected to the boundary in any one of the 4 directions, top, bottom, left and right, okay, that means from any of the those cells we can walk out of the grid, isn't it? So we will sync this, then we will sync this connected land cell, then we will sync this connected land cell, then we will sync this connected land cell. Similarly we will sync this one, then this one, then this one. We will start from the boundary and spread out. Similarly we come here, it's a 1 here, right? From here we spread out, and spread out by doing what? By syncing it. That this land cell is useless, okay, so we will sync it. And after syncing all these land cells, finally the land cell from which we can't walk out of the grid will be remaining. Okay, so this will remain, this will remain, all these yellow cells would remain, and we will simply traverse this grid and we will count the number of ones. Okay, so this thing that we did, okay, syncing this land cell, how are we going to achieve it? If you watch the video that I posted yesterday, I did something like this. What I had said that, let us assume we are on a helicopter, okay, and in our helicopter we have a lot of people whose task is to sync the land cells which are connected to the boundary. So our helicopter will as usual traverse, okay, fly around. Okay, as soon as it sees that it's a land cell, it will drop all the people on that land cell, and what the people will do is it will sync this land cell. Then all the people will spread out, okay, spread out in all 4 directions and sync all the connected land cells. Okay, sync all the connected land cells. So what did we do? We did a DFS. Okay, so what are we going to do? We are going to traverse on this grid, okay, and if we see that there is a land cell on the perimeter, okay, or let's say extreme rows and columns, 0th row, 0th column, last row, that is r minus 1, and last column, that is c minus 1. Okay, if there is any land cell in this particular row and column, we will start syncing that land cell from here. Okay, we'll sync that one, and we'll sync all the adjacent connected land cells. Okay, so ultimately the land cell which are not connected to the boundary, okay, they will be remaining, and we will count them and return it as our answer. Okay, so let's see the code. This is a very easy problem. Okay, so this is the solution. Okay, it's very easy. We count the number of rows and columns, and we start iterating. Okay, if we are standing at the first row or the last row, or if we are standing at the first column or the last column, okay, and if it's a 1, okay, that means if it's a land cell, okay, then what we will do, we will call our DFS on it. That is, I have named the method as sync land. We'll sync the all connected land cells. Okay, all connected land cells, we will turn all of them to 0. Okay, we'll make them useless because they are, isn't it? After that, all the land cells which are connected to the boundary would be turned into a C cell. Okay, then we will easily count the number of remaining land cells. Okay, they are the ones which are not connected to the boundary. Okay, so this is that for loop. Okay, number of enclaves, int enclaves, we simply iterate over the grid, and if it's a land cell, we increment it and we return it. Okay, now this is the DFS method. Okay, if we have moved out of bounds, then return. Okay, if it's a C cell, then also return. It's no use to move into that cell, isn't it? Otherwise, sync the land cell. Okay, and after syncing that land cell, move in all 4 directions: left, right, up and down. Okay, so it will move recursively in our matrix. Okay, and turn all the connected boundary connected land cells to a C cell. Okay, make them useless because we don't want to count them when we want to count the number of land cells which are not connected to the boundary. Okay, I hope you don't have any confusion. Okay, so this is the simple DFS method, and this is the method to check if you are standing at the 0th row or 0th column or the last row and column. Okay, so this is nothing. Okay, so this is the simple solution. It is very easy. This is just traversal. Okay, DFS traversal. So I hope it's clear. Okay, if we talk about the time complexity, as usual, it's going to be a big O of m into n. Okay, or r into c. Okay, and the space complexity is also going to be a big O of m into n. Okay, so this is the solution. Okay, I hope it's clear. If you have any doubt, you can ask me in the comment section. And other than that, if you like this video, do hit the like button, share this video and subscribe to my channel, and I will see you in the next one. Also make sure you watch my yesterday's video, that is number of closed islands. Okay, so that problem is very similar, DFS on a matrix. Okay, so yeah, that's all. Bye bye.